Misheck Meya is from Trident College. Trident College is in Zambia, Misheck. Am I correct?
Yes, you are correct. It is in the northwestern province.
Okay,
In Solwezi.
beautiful. Oh, beautiful. Thank you. So Misheck is going to be speaking to us so his talk is titled Rethinking Problem Solving in the Teaching of Science to Learners. Then the brief description says this session will be on how we can improve science learning by developing reflective learning skills in learners. How do we foster deep learning? This sounds quite interesting. Then over to you, Misheck. You can feel free to turn on your camera so that they can put a face to the voice.
Okay, no problem.
If you're comfortable with it, yes.
No, it's fine. It's just that I don't know if my camera is that clear so that you're able to see me.
Okay.
Yeah.
So you can turn it on for a moment and switch it off. At least they
Yes,
would know who is talking on the other side.
Thank you so much. Okay, let me just share my screen now. Okay, are you able to see my screen?
Yes, we can see your screen.
Okay, thank you so much. So as you shared, I'm going to be sharing about how we can enhance problem solving in the teaching of science, specifically to the students that we teach. So I'm going to try by all means to use the concept of metacognition to actually cultivate the thinking that we want in our learners. So like here said, I'm from Trident College. So Louis, it's sort of a high school setup, but we have AS and A level grades. So that's why we call it a college. So we are from year 8 to year 13, so to say. Okay. Are we good to go?
Yes.
All right. Okay, let's begin. It seems like I'm facing the same challenge. Okay.
What's the challenge? Is not moving
okay,
to. Okay, we
it
can
was
see the next
moving.
one.
Yes, that was the issue. Yeah, so as educators, the problem that we face is evident. Science often is taught as facts, not as thinking, and which is a problem for us because from this we see that learners are going to struggle to apply the information that we give them. We know that science is facts, but we are not teaching it as a thinking science, meaning that learners are struggling. They are failing to find the connection between what we teach in class and what they can do with the real world. So that is a problem. So now, when I was preparing this, what mostly was at the back of my head was that the traditional problem-solving methods that we use, they overlook how our learners think, and this is a challenge for us. So we need to raise thinkers, not memorizers, because when we do that, then it is going to help us shape learners that are able to solve problems. Like I've said, we are looking at rethinking how learners should learn in terms of how they think about their learning. So now, because of this, learners start to pass, not to learn. Teachers here, I believe most of you, if your first questions or statements, such as the one that you can see here, a student would come to you and tell you to say, I studied all night, and today I'm unable to remember anything. So you see from those statements, you see that there's a problem. Learners are studying, but yet they're unable to retain the information that they've studied. So there's something that is missing, and that is how they view the learning, because they're not studying to learn, they're studying to pass, they're studying for grades, which is very, very difficult for us to motivate them. So what do? We need to create a culture in them that is going to allow them to be deliberate about their learning, to think about their learning. So this is the challenge that we have, and I'm going to try as much as I can so that we can see the value of this. And again, as we've seen in the recent past, it demands for us to change the way we teach science, because of the fact that we don't know what our students are going to be doing in the near future. We don't know the jobs that they are going to be doing. Who knew that we're going to have prompt engineers? We never knew that. So this is very important for us now to teach problem solving, not just facts, because if we can do that, then our education that we're providing is going to be sustainable, meaning that whatever we impart today is going to be used in the future. So this is uh, what led me to think about how can we, rethink and also use strategies that are going to actually cultivate a thinking culture in our students. The World Economic Forum in 2023 estimated that 44% of workers' skills will be disrupted. And this has happened because, like I mentioned, we knew that we're going to have, prompt engineers. A lot of laying off has been done from huge companies, and that is affecting uh, a lot of workers because the skills that they have, they are not adaptable. And so, what can we do in such a case? We are teaching now, and we're experiencing this as educators. So it is very important for us now to change how we teach so that learners fit into the jobs that are going to come in the future. All right. Okay, so now, like I mentioned, we're going to be using metacognition to shape that mind, to shape that learner, how they can think about their learning. So metacognition is simply thinking about thinking. So in this case, what we're trying to do as teachers is telling our students to recognize their strengths, to recognize their weaknesses in as much as they are learning. If we teachers have teaching methods, then it is just fair for us to say that learners should have learning methods. How can they learn something that they want to learn? So it is this question that we need to address. Learners need to know how to learn, and we can use metacognition to shape this. As we are going to see, problem solving, or as we already know as educators, problem solving is a skill. Now, metacognition, even though most of us don't recognize it, is the backbone of that skill. You use metacognition in the daily task as you solve a problem, just that sometimes you don't recognize that you are performing or you are using this concept. So it has the following key concepts or aspects. So it is imperative that when you are using this concept, learners are encouraged to plan before a given task. Let's say, for example, I want to be teaching on, let's say, Hooke's law. You would want them to plan before they engage with uh, the experiment itself. They need to ask themselves, what strategies can I use as me as a learner to actually learn this new concept? What skills can I apply? What helps me learn better? So that is what they can do in their planning aspect. Then monitoring, as they choose those skills and strategies they can use, they should be asking themselves, am I making any progress in the learning? And where am I stuck? As they do that, they are creating a culture of being deliberate about their learning. Because another challenge, like I've mentioned, is that our kids are starting to pass tests and not really learning. So it is a challenge for us if they don't make deliberate effort in their learning. So after they monitor, after a given task is done, they need to evaluate. And this, which we are talking about, should be taught. Learners usually don't know how they can take ownership of their learning. So as educators, we need to be deliberate as well, teaching them how to plan before a given task, how they can monitor their learning, and how can they give an evaluation to their learning as well. So it's very important for us. So what happens is they'll plan, monitor, evaluate. When they evaluate, if they see that the strategies they used were not working, they can plan again. Now, what this is going to do is that it is going to bring about continuous learning, because our goal is that learning should continuously happen. We don't want to have, you know, breaks in the learning process. We want continuous learning in our learners. So if they plan, they monitor their learning, evaluate what is not working and what worked, then they can go back to planning again. How best can they learn after looking at the things that didn't work and the things that worked? Then from there again, they monitor. So it's a cycle. It's a cycle like that. And then the learning continue running like that. Eventually having what we can call spiral learning, which is better learning because it leads to deeper thinking and understanding of concepts. And in our context now, we are talking about how we can sustain that thinking, not just from our physics, not just from our chemistry, our math, our art, but also from the jobs that we don't yet know our learners will do. So we want them to have this sort of couch of thinking whereby they recognize a mistake and just act upon it rather than seeing that mistake or um, the problem that they are faced as a barrier to their learning, but they should see that as an opportunity to actually continue learning. And I think that's the challenge most of our learners don't. They could just say, oh, please tell me this is correct. They don't want to hear about the wrong answer or what they did wrong. And as educators, we need to shape their minds in a way that they need to look at these mistakes as learning pointers, not as, as failing points whereby they are discouraged, but they should be encouraged to research more, to continue learning, because like we are saying, when we have such a mindset, we are going to bring about learners that are going to be problem solvers. They'll be able to solve problems knowing that when they fail, it's not an end in itself, but a step to continuing to research and to learn more. Yeah, so the other two key aspects of this education concept that we can use in our classrooms is that it involves what what information is available for me to learn, or in this context where we want our learners to think about their thinking, what do they know and how can they learn the things that they don't know? What do they know now? And how can they use that which they know to learn something new? So it involves the metacognitive knowledge. What do I know? Who am I? What sort of skills do I use when learning? What helps me? That is knowing what they are capable of doing, and then also recognizing what they can't do. And then from there, it involves another aspect that is called metacognitive regulation. Here now, like we've said, is where they ask a question of how do I plan? How do I monitor and evaluate my thinking? Because like I said, if we have teaching methods as educators, why can't we have learning methods for learners? How can they best learn? These are the questions that we are asking ourselves, and how can they best improve their thinking so that they can actually use that information in new situations and eventually solve a problem that they've never met before. I remember during university times, what I had faced is that usually when you don't know the problem that has been asked, and if you've never solved it before, we were struggling to the point that it was very difficult for us to solve. But what if we were taught on how to think, not what to think? So those are the questions that we should be asking ourselves. Now, what this is going to do is that it will enable learners to make control or to take control of their learning. And then this is going to bridge the gap between just doing science and thinking like scientists. In other words, we want our learners to be thinking like scientists, not just telling them what scientists have done. So that's what we need to be thinking about. Okay, just more emphasis on the same cycle of metacognition. So it involves planning and setting goals. And then here, our student is going to analyze task contents, what is going to stop them from learning effectively, and then what is their belief about learning. This is again very important for us as educators. We need to have a belief system that all learners can learn or can achieve. And if we don't have that atmosphere in that learning environment, it will be very difficult for our students to have a mindset that is called, that is culturally, oriented to growth. So in other words, what we are saying is, as educators, we need to believe that all students can achieve. And then if that is communicated to the entire classroom, then you're going to have students that are going to think about ways and means of solving the problems that they encounter, not just in the physics lesson, not just in the chemistry lesson or bio lesson, but even in their daily lives. Remember, our goal is to sustain the thinking and to adapt into future roles that are arising, from nowhere. I can say from nowhere because I never knew that we're going to have property engineers. Yeah, so we plan, we set goals, and then from there we apply these strategies and monitor the learning. From there we get motivated and evaluate. And then after that, if it's not working, we adapt to new things that we can use to actually get to the learning. So this is something that we can leverage as educators. So teach this to students so that we promote continuous learning. Learning should be continuous. And we know that if learning is continuous, this is going to lead to deeper learning. And we know better learning equals, rather, deeper learning equals better learning. And this is going to result in better thinking and also a different outlook on learning by our learners. So this is very important for us. Goals shape how we practice. So when we set goals, we're going to have to go into practice. That practice is going to lead to the performance that is going to be seen. And then from there, you're going to gauge. You're going to ask yourself questions: what worked? If I've gotten this much, what can I do better so that I can get much more from the learning or benefit more from the learning? So we are saying when we set goals, we are going to shape our practice or what we are going to do. In this case, this applies to our learners as well. When they set goals in their learning, they are going to know when to do something. They're going to know how to evaluate their performance. And also from this, they're going to give them feedback. They'll get the feedback from the learning, which will result in continuous learning, like I've said. And this is what we need because we want learners to be deliberate, not to be forced. Learning is very hard, as we already know. Um, we all struggle in learning, but what if they just have that culture of thinking about their learning and how better they can be? So what can we do in our class? How can we make metacognition work in our class? So use things like think aloud during demonstrations, encourage science journals for reflection before, during, and after tasks. Ask metacognitive prompts like what was tricky about this? You ask the learner that question, they'll be thinking about the whole process of their learning. What would I do different next time? So there you're now trying to tell them to say, if this didn't work, what other skill or what can you do differently so that you get better results? We need to integrate group reflection tasks post experiment. After our experiment is done, can we now have reflection tasks so that we model continuous learning, like I've mentioned, and we model problem solving because we just don't want to give facts. We want them to actually think like scientists. The way, let's say, the way Newton, was thinking about gravity. That's what we want them to be, to be as well. So that's very important for us. So don't just ask what did you do? Ask what were you thinking when you did that? Again, here we are not just trying to have a baseless, analysis of or giving a feedback that is not really rooted in metacognition. We want a feedback that is going to prompt action from our learners, because sometimes we usually give feedback that is short-lived. Well done, you did well, and that's it. But that feedback is not really helpful. Why? Because you don't want to just tell them what they did well, but you also want them to continue learning. So what can you do to provide that continuous spectrum of learning? So when praising learners, avoid vague praise. Be specific in your feedback and be goal-oriented. Ensure to orient learners to act on feedback so that can enhance their problem solving. We can use what is called the made on mission model. So what this is about is you need to tell the learner what they did well. So that is the medal. It's like you've given them a medal, like the medals that we give for, winners, Africa Cup of Nations. No, you've won. So here is the medal. In our context, you would say, you've done well. I saw how you worked throughout in your problem solving. I love the method. Now, what you could improve on is this. So that is a mission that you are giving the learner so that they continue learning. What you don't want is to have learning stopping. You want it to continue even after the learning has taken place. So, how can we use metacognitive feedback to ensure a spiral of learning? Like I've said, we can use the meta and mission feedback. So, for example, you can have a learning objective. Let's say use particle theory to explain how temperature changes affect gas pressure in a container. And then we are assuming this has been done and you just want to give the feedback based on what they have done. So the learner could tell you to say the balloon gets bigger because the heat makes the particles move faster and push more. So from there, what you can do, you give them a medal. What was good? Well done for using the particle model. You correctly mentioned that heat increases particle movement. That shows good understanding of how temperature affects gas behavior. Then from there, you don't end just there. You give them a mission now, because as a teacher, you obviously you are a master of your subject. You would have noticed to say they are not associating the speed from the increased kinetic energy and etc. So you'd want them to actually now think a lot about the answer so that you continue that spiral of learning, which is revisiting the same concept now with more greater depth, because that's what we want. And from this, what we are trying to do is building a couch of thinking and eventually problem solving. So you could say, next time, try to explain how faster moving particles cause the balloon to expand. You could add that increased particle speed leads to more frequent and forceful collisions with the walls of the balloon. So this is an example of how you can use metacognitive feedback, and we can use an example of a made mission. You can adapt this. Yeah, this is just an example for us to actually see how we can improve the thinking and also the learning in our students. Okay, what else can we do? We can use I used to think before the task. Now I think after they have learned. So that's that's something that you can use in your classroom. So you can have a poster, let's say in the corner, and then you have one chart written I used to think, and then another poster in another corner you put now I think, so that you promote that spiral of learning, that thinking, and the reflection as they learn. Because remember, we want our learners to reflect on their learning so that they are better learners and problem solvers. We can use metacognitive journals, during investigations, encourage student designed experiments. This is very important because again, what we are going to see is that they are going to plan, test, and evaluate. From there again, what we are trying to do is to make them think like the scientists, not what scientists actually did. When we do this, we are promoting problem solving. Again, promote group reflection cycles after tasks. This is very important to encourage peer learning, and also to it's the I have myself I learn better when uh, people maybe paraphrase things that was talked about, and from there, personally, I feel it is very important for learners to reflect in groups so that they can even pick up some things from their peers. So some prompts that you can use: what was your strategy? How would you use it again? And another thing that we can use in enhancing reflection in our classrooms, we can use KWL chart and reflection tools. So let's just see how we can use these two. So here I have the KWL chart, and the example that we're going to use is pressure in gases. So they are going to have the K, which is what do I know about the topic, and then what I want to know is the W, then the last one is the L, what I learned. Again here, so you may tell your learners to actually fill in the first two parts before they fill in the last one. So they could say, what do I know about pressure and gases? Here takes up space, they put that down. Balloons expand when filled. Gases are made up of particles. That's what they know. What do they want to learn? Why does heating a gas increase pressure? How do particles cause pressure? What happens to a gas in a closed container? So now you need to be careful as you do this. Um, Remember, you are teaching a curriculum that demands certain competencies. So you need always to reflect the KWs to the learning objectives. That's very important. But again, in your mind, your target is that your learner should be able to think and apply new knowledge in new contexts. Okay, then on the right hand side, we have another reflection tool that you can use. So it is almost the same as the KW, but here now you can have now the targeted question as you, the teacher. Yeah, so what was easy to understand in this lesson? The learner should put there. What was tricky or confusing, the learner should put there. And then the skills that they used: was drawing pictures or diagrams helpful to me? Was watching experiments helpful? Talking within my group, asking questions, taking notes. So they need to recognize their strength, what was working as they were learning. And then one question I still have: how would I explain pressure in gases to a friend? They fill in these so that we continue the learning process. And essentially, what we are trying to do is for them to be deliberate, to be self-aware of how best they can learn. Yeah, and I think In conclusion, let's shift from teaching answers to cultivating thinkers. Metacognition empowers learners to own their problem-solving process. The future of science education lies in developing reflective, resilient thinkers. Let us rethink, reframe, and reignite the way we teach science. Our learners must be taught how to think, not what to think. Remember, problem solving is a skill, but metacognition is the engine behind it. Believe all learners can achieve and engage in higher order thinking. Expect reflection from every learner that you teach, not just from the high achievers. So the point here is that we need to have a belief system as educators that empowers every learner, and the belief system should be that every learner can learn. As Albert Einstein said, he said, everybody is a genius. So therefore, it is just us as teachers what we do in just igniting that potential in that learner that we're teaching. And then John Hattie said the following: metacognition turns learning into deliberate act. And I think this is what we want our learners to do, to be responsible for their learning, not just us giving content and pushing them through every day, but they need to be aware of the learning. And as we strive for this, let's remember the jobs our kids, our students that they will occupy later in life are not yet there. So we should teach problem solving that is going to be sustainable even after high school or exams that they're going to do in their various curriculums. Thank you so much.
Wow. I wish one of the PSP team members could make a comment to what you just shared. Anybody in the session?
Good afternoon, colleagues. I
Hi,
just
good
want to
afternoon.
take away one good thing, or maybe two, that every child is a genius. If we can, colleagues, have that belief within ourselves as teachers, I think we can create the whole total different new world out there as far as the children are concerned. Who doesn't want to become a winner? Number two, teaching how to think versus what to think. That stands out for me. Thank you so much to the presenter.
Thank
Wow.
you. Thank you. You're most welcome.
Thank you, Nzeke. Anybody else who wants to comment or ask a question, colleagues? Let's feel free. It's a safe space. Okay, I see Amy, your hand is up. Please unmute your microphone.
Hi, I just wanted to say it was a great presentation. I wanted to hear by you your comment that you said, yeah, we need to teach the learners how to think and not what to think. The high order questions in formal assessments constantly look or allow the children to think a bit on their own, take the work that they've learned and be able to apply it. So it brings in the how to think, but still children struggle with the formal assessment's high order questions. I personally integrate creative art to try and bridge the gap and make it more alive for the kids. Is there anything else that you would recommend to improve the children's metacognition in regards to the formal assessments?
Yeah. I think my comment on that can be that, as we have already said, yeah, the challenge that we have in our learners is sometimes even them, depending on how the teacher looks at them or the outlook the teacher has on the entire classroom, they tend to actually label themselves. even if your intention as a teacher is not that. They tend to label themselves, so they usually give you those low stakes. They give you what they feel they can offer you in that learning process. So my contribution to that, or my suggestion, is that we want to just make them realize to say learning is a process. It's not just a once-off thing, and we are supposed to improve. And if that is not communicated to them, like I've said, they'll continue thinking they are boxed in that, and that is what they can only offer you. Whatever they do at their current state is what they can offer you. But shape them in a way that they will look at mistakes, they will look at challenging problems as a learning point, and not just something that is going to stop their thinking. So now what can you do? You can scaffold questions that you can look at a given question, then you break it into pieces, and then your goal is to make sure that no matter what, they should attain the same understanding as these others, whom we can call those who are there and these who are not at that level. So try to scaffold questions, give questions that um, are going to match their level, but at the same time provide that support that is going to move them out of that comfort zone and start thinking about how they can tackle that challenging problem. What can they do? What sort of strategy can they use in order for them to move from the current information that they have to another one? So just create that environment where every learner is going to believe, to say, if I failed to answer this, it means that something wasn't done well. So what can I do now to move forward? Do I need my teacher to help? What question do I have? What is making me stuck? Let them know that failing is acceptable, and making mistake is a way of learning. We learn from mistakes, and if they can recognize that, you're going to be better off. And again, this works for every learning classroom. It could be high school, it could be junior secondary, it could be primary. This works. It just us as teachers, we view kids as kids, but we can cultivate that thinking culture even at tender ages. So I don't know if that is helpful. Yeah, but my point is scaffold, support. And again, just let them think about their learning, and also accept that a growth mindset is what they need to look at mistakes as learning pointers and be motivated regardless if they fail. Thank you.
Okay. Thank you for the question, Amy, and thank you for the response, Misheck. Anybody else with a question or comment, colleagues? While waiting for more questions and comments, let me just quickly check if KV Rahul is now with us from the Prince Shri Engineering College, who's supposed to be one of the speakers today. Are you in here with us? I think that's the device named VK, if I'm not mistaken. Or it's a different person. KV Rahul, one of the speakers to be speaking today. Are you in here? Okay. You can go ahead. I see Zorina's hand is up.
And could I also ask whether the objective of bringing in that kind of problem solving that Amy's talking about, informal assessment, can that be achieved through project-based learning? I'm asking the group.
Yeah, I think it is. It can work. It can work. Actually, that's one of the things that you can use. That is one of the recommended aspects that you can, embed in your formative assessments using project-based assessment so that learners can do hands-on learning. They can work on things on their own and then see how their learning is developing. It can actually work, at least from my point of view. That is very workable.
And so within that, you scaffold your questions from your lower order to your higher order questions within the project as the children solve a problem. So they work towards not necessarily a problem, but an issue, a topic that has come up or something that is of interest for them. So you then select the topic and then explore through questions. And thereafter you scaffold the activities, including your higher order questions. So that for me makes sense to situate it in project-based learning. I'm just asking the group again. Sorry.
Anybody who wants to respond to that? Or if Misheck, you want to respond to that?
So if I got you clearly, you were asking if in the project we are supposed to scaffold questions from record to creation or to synthesis. That's the question. Yes. Of course, we cannot just forget about the words. Yes, it's very important for us to actually move from the record or the comprehension, which is understanding, to actually now using information in new situations. Our goal is to make sure that learners think. So now, in doing so, we are not saying we should abandon the creation, the recall part and the comprehension, because that forms the basis for them to actually now think much about their, let's say, content. If you are looking at it in that way, that forms the basis of them having skills to apply or using information in different ways, because firstly they have understood, they can recall, but your goal is not for them to end on it, recall and comprehension. How can you push their strings? How can you stretch them to the point that they can now solve problems that are not even related to the current problem? So that is our goal, because like I was mentioning in the discussion in my presentation, the challenge that we are going to have is having people that don't have skills to actually apply in jobs that we don't even know exists as at now. So what if we can have students that graduate and still be able to apply information that they know in a different way and still be successful? Because if we just end on recall and comprehension, it means that it's a problem. We are just going to have people who have content, but yet they cannot really do something outside that comfort zone of that information they have. Yeah, so I think that's my suggestion. Our goal is to make sure that we use these two steps, recall, comprehension, to another, leading to these others, higher order, stages in our students.
Yeah.
Absolutely. Thank you for the questions, Dr. Zorina Dese, and thanks for the responses once again, Misheck. Yes, Emmy, you can go ahead and unmute.
Just for the comment or the question from Zorina, I make use of problem-based learning throughout my term, throughout all the subjects. One I found was that children really enjoyed was in term 3, we do electricity, and the learners that have to write the learners have a diagram, and it says, okay, so the light bulb is here, and there's a switch, and there's a battery, but the globe is not working. And then you actually give them those components. They need to try and figure out what is the problem, why is it not working, and how can they correct whatever it is that is wrong. Not only do are the children more engaged in their own learning process, but it makes it fun for them as well, which also allows the learners to remember it for longer. When it comes to including that in the formal assessment, you can make use of rubrics, but rubrics have to be very precise so that it's easy for you to be able to mark the children whether or not they were able to formulate their own, identify the problem, and then identify how to fix it, and actually be able to fix it, not just say this needs to be done, but they need to then be able to do it as well. So rubrics, I find, helps a lot when it comes to that, because you can't really mark with a memorandum when it comes to problem-based learning, because there is, not all children will get to the same answer the same way.
Yes.
One will take
a
route
different
A,
route.
and the other
Yeah.
person will take route B, but they get to the same answer. And that how, as Misheck refers to, they need to think of how they're going to solve the problem, how to think, and the way children thinks are different.
And the wonderful thing, Amy, is now that we have ChatGPT, you don't have to struggle with rubrics. Very helpful. You give the criteria for maximum and minimum, and you ask for a scaffolded rubric, and voila, Bob's your uncle. He gives it to you.